Very grateful for our two speakers to join us today. So Joe Stevenson will be giving a presentation on starting the market for fuel cell vehicles. Joe works for Arcola Energy in the UK and is responsible for commercial relationships, working to deploy fuel cell electric vehicles in commercial and public fleets. He has a wealth of experience in transport and energy, and having previously worked for Johnson Matthey, developing their clean energy technology strategy. The two presentations. I'll monitor it in the chat, and then we'll follow that up at the end. Okay.
Thank you. So I will briefly introduce Arcola Energy, which I think is necessary context for this. I will talk about our area of expertise, which is hydrogen powertrains for heavy-duty vehicles. I'll say some words about how introducing heavy-duty hydrogen vehicles helps the development of the energy system and the hydrogen economy generally, and then look at the market approach and the practicalities. So we're a business. This is very much about the practicalities of doing it and what people are prepared to pay for, which I hope, based on Tony's introduction, will be a helpful context for you, particularly as you start looking at the economic case for hydrogen. So this is what we are. We're a specialist in hydrogen and fuel cell technologies, and the focus of the business hasn't always been, but it is now very much on transport and particularly heavy-duty vehicles. So what we do, we're a systems engineering company. We don't make fuel cells. We have made fuel cells in the past. We know how to do it, but our role now is very much as a system integrator and as a tier one supplier. So the business was founded 10 years ago to bring these technologies to market very specifically by people with an academic background in the area. Our founder and CEO, Ben Todd, has a doctorate in Cambridge in solid oxide fuel cells. And it was about the practical application of these technologies, not specific to one application at the beginning, but as people have been interested and as opportunities have presented to deploy fuel cells, so the business has evolved. And as I say now, it's very much looking across the whole value chain, doing everything that we need to do to be able to deploy fuel cell vehicles. There's a very strong emphasis on what it takes to do proper commercial deployment, particularly on quality, safety, and on compliance. So I say there's a full spectrum of what's required. Market creation, it seems a strange thing, but there is a lot we have to do at the front end to sell the concept of hydrogen transport and explain the practicalities to people who are already interested in zero emission fleets of vehicles. So we will go out, we will look for partners, we will look for willing users who understand what it is that they want and what we can offer. We will very often have to look for funding to bridge the gap between the cost of existing technologies and these early fleets. And then we also manage projects as well through to completion. The core is around engineering vehicles and developing product suitable for customers' requirements. We then manufacture powertrains or integrated powertrains into complete vehicles, and then we support the vehicles once they've been deployed. So we don't do all of this in all of our projects. Some of what we do involves only one of these stages, but quite often, if we're responsible for full deployment, it will be from beginning to end in this process. So this shows you the core of the business. It's a systems engineering business, and the benefit of the experience that we have and the view that we have across all stages of the process are in these sort of three areas. It's understanding full life cost, and in sometimes being able to manage full lifetime costs and explaining it to our customers. So that's critical. If you've got somebody signing up for a vehicle with a 15-year useful life, potentially, and they're used to understanding all of the costs of the vehicles, then that's very important. Understanding the supply chain, what's possible, what's cost effective, and how we can use what is available in the supply chain, and bringing on new suppliers is an important part of what we do. And then I think what's really important is that practical application experience. So I say we've been going for just a bit over 10 years. This has been the trajectory of development on vehicle building. At the beginning, the interest was on particularly very light cars, micro cars, a couple of projects there. We did our first heavy vehicle, which was a prototype bus in 2014. Done some stationary projects. We did a van. We demonstrated a double-decker bus with Alexander Dennis Limited in 2018. We've since moved on, done projects in non-road machinery, hydraulic machinery, and the most recent project then is a bin lorry, a refuse collection vehicle. So there's a clear trajectory there, which I think follows the shift in interest over the last 10 years in the application of hydrogen in transport, from looking at passenger cars, and particularly the lighter end of passenger cars, now through to an understanding that the most fruitful applications from an energy system point of view, but also from a user point of view and therefore a commercial point of view, is at the heavier end. Here's an example of two vehicles that have been recently announced. We announced in April the development of a fuel cell bus with Optimising, is a double-deck bus manufacturer near Leeds. And then I've already mentioned the one on the right was one that we did with Alexander Dennis, who are mostly based in Scotland now. They're two of the three big double-deck bus manufacturers in the country, and I'll explain later why buses such as these are a very useful lead application for us and for hydrogen transport generally. And here is one of my colleagues with two of our customers and a van. So these are vans. They are battery electric vans with fuel cell range extenders, and the fleet that we run for customers, some owned by the customers, some leased to customers by us, is the largest fleet of fuel cell commercial vehicles in the country. So, and these run from the north of Scotland all the way down to the south of England. So these are vehicles that we've been running for 4 or 5 years, and the practical experience of helping customers run these vehicles, looking after them and getting the customers to understand how to look after them has been massively valuable. So now we just look, this may be familiar to a lot of people, but I'll talk about the hydrogen powertrains, the work that we need to do to make them as good as they can be for practical application in customer fleets. So the key elements in a fuel cell powertrain are these. You have the fuel cell system, of course, but you also have all of the high voltage electronics to think about, and there's always a battery. So when I was first involved in automotive fuel cells more than 20 years ago, the fuel cell was doing all of the work. The fuel cell was having to provide all of the transient response, all of the transients in the power demand for the vehicle. One of the nice things about the advances of battery technology is that hybridization is a lot easier with the fuel cell in that orange high voltage system across the middle. The hydrogen tanks are clearly critical. In all of our work, we also have to think about matching this energy supply system for traction through to the traction system itself and the motors. but also to the other vehicle systems. And on a heavy-duty vehicle, particularly something like a bin lorry, we may be driving hydraulics, things in a powered body that we need to take account of, as well as anything to do with keeping the lights on, keeping the driver and the passengers warm, etc. So that's the piece that we take responsibility for. We talk about these are the types of, this really the system optimization piece. Hydrogen tanks are large and still, unfortunately, quite expensive. So understanding how much we need to meet the customer's requirements and what we can easily package on the vehicle is therefore very important. The fuel cell system and sizing the fuel cell system and specifying the fuel cell system is about understanding what the base load requirement of the power of the vehicle is. And the battery then is for power peaking, for absorbing regenerative braking, taking excess energy off the fuel cell when the fuel cell is providing more power than is needed by the traction system, but then also helping the fuel cell when the vehicle is accelerating, when it's climbing a hill, and there's heavy work being done on powered equipment on the vehicle. So it's that piece optimizing the power and the energy and the delivery of the power in a way that makes it as cost effective, as efficient, and as durable and reliable as possible. And that's what we do. So, you know, what we talked about, the shift in emphasis in the market on the application of hydrogen in transport. And a lot of that's been driven by advances in battery technology and in the industrialization of automotive pure battery systems rather than battery fuel cell hybrid systems. Whenever we're looking at a deployment, we're always looking at advantages over diesel, which are mostly related to emissions. But you know, customers like other things. They like less noise, they like less vibration, they like fewer air pollutants, they like lower running costs if we can provide that. But it's also looking at batteries, and when people have decided they want a pure zero emission fleet, then clearly the choice is going to be between battery only vehicles, plug-in vehicles, and fuel cells. A lot of it comes then down to weight, and the weight of the energy storage determines how much energy can be packaged onto the vehicle, and that's the key differentiator. In terms of their power delivery and performance, their equivalent, the thing about the fuel cell is you can get more energy on the vehicle and it can go longer. There are other advantages on the infrastructure side, which I'll talk about later, but one of the things that we're always looking at is the applications where a fuel cell has a material performance benefit over a battery system. If a battery only system is sufficient, then that's the one that people ought to use. And here's a very practical example derived from a bus. So you want to run a bus for 15 hours a day. I mean, the ones in London run for 18 hours a day. You need the range. You then work out how much energy you need on the bus, and you work out what that means in terms of weight. These vehicles are all weight limited. And what that then means in terms of passengers. And the number of passengers you can get on the bus determines how much operational support that you can, as well as how much direct passenger revenue you can get. So this is where the technical practicalities of the different systems flow very directly into the benefits for users and our ability to make a proposition that people will buy. You know, in this particular example, you can see that the weight saving of a fuel cell system over a battery translates to 60 passengers in a bus that has usually a packed capacity of about 95. So it's a very significant. You know, when we're looking at the advantages of hydrogen in the transport system, I said that we're looking at the alternatives that people have. and where we can make a good case. Whereas people move away from diesel, the benefits of electric drive and regenerative braking are clearly around energy efficiency. One of the reasons that we look most often at urban city driving is that the benefit of regenerative braking is greater relative to diesel than it would be for long distance, higher speed driving. So that gives us more of an advantage that we can then use to attract the customer, because practically, I think this matters, the customer will look at the cost of fuel. And that then goes into efficiency. And if you can show a greater efficiency gain relative to diesel, that particular application can tolerate a. So also the application translates directly into the commercial case and the willingness of the customer to adopt the technology. Mass is very important in these vehicles. They're payload limited very often, not always, but very often. And customers want to be able to carry the same number of passengers or the same amount of cargo over the same distance with the same operational patterns that they have now with diesel. So fueling rates are very similar. I'm about to move on to it, but I'll start talking about it now. In terms of the energy system and the hydrogen, the refueling infrastructure is a critical piece of this. And so one of the other reasons for looking at urban vehicles is they always go home to the same place every night. So one refueler can accommodate a whole fleet of the few exceptions. Germany's getting there, probably the most advanced country, certainly in Europe. There isn't anywhere where you can drive nationally easily on hydrogen. So one of the challenges we have in bringing hydrogen transport to new fleets, everybody would like to try one or two vehicles to begin with. Providing hydrogen refueling for one or two vehicles is costly on a per vehicle basis. It's the cost proposition for hydrogen fueling gets much better if you're doing the whole depot, because the electric charging, the costs scale linearly until you have to increase the power supply to the site, and then you get a big step change. But that comes after the first few vehicles. With hydrogen, it's rather different. The first installation is the most expensive one. And generally, depending on how the hydrogen is delivered or made on site, there are not very large capital outlays in the cost of delivering hydrogen to larger fleets. So the key message is always to look at the whole fleet and plan forward for the economics of a whole set of vehicles, not simply looking at what can be delivered in for the first vehicle. We also, wherever possible, try to combine users so we can further defray the cost of the hydrogen refueling infrastructure. As far as how hydrogen fits into the wider energy system, when we are looking for projects to develop, we are looking for opportunities where there is value in decoupling renewable energy generation from the demand. So this is most relevant for hydrogen production by water electrolysis, where we will be taking a feed usually from a wind farm, and the opportunity to store 2 or 3 days of hydrogen on site gives us an opportunity to be completely self-sufficient with regards to energy, using just the wind power, but not having to worry too much about the intermittency of the generation. That's one practical benefit. The other one is that I think this is the first really commercially viable application where we can deploy hydrogen generation and use at the megawatt scale. There are many, many future applications for hydrogen across the energy system. We will talk about those later, I'm sure. But in terms of getting the market moving, increasing the number of units that are made, bringing down the cost of the equipment, and building the skills level, this is a viable early application, which is one of the reasons we concentrate on it so hard. So this is my last section, and this is just about the practicalities, how we go about deploying fuel cell vehicles in the field and exploiting the benefits from the customer's point of view, but also delivering the benefits for the energy system. And the package has, you need vehicles, clearly. You need fuel. It is not enough for us to offer vehicles. We have to be able to show where the fuel will come from. We have to provide close technical support, we know from experience, and the whole thing really needs to be delivered as a package. Understanding the use case for the customer's sake and for our sake is very important. We do a lot of work up front, looking at use patterns, looking at the weights on the vehicles, how they will be used, so we can determine the suitability of the vehicles. We then do the powertrain system integration, which I described before, where we are focusing on balancing the system and controlling it in a way that delivers performance in terms of the vehicle performance the customer wants, but also reliability and durability. There are huge differences in all of those three factors, depending on the way the system is constructed and controlled. And then integrating these systems into the vehicle, the most important thing is safety, but then there is also packaging. You know, the vehicle has to be usable. And then also, we have to be able to service it. If we package it too well, we can never get to the pieces that need attention. And that causes trouble for later. So that's the approach. There's an example of the approach that we have exhibited publicly. Very good energy storage on the vehicle, able to run all day fully loaded, very efficient, and the efficiency drives low running costs, which clearly are very important, particularly for people operating in relatively low margin applications like public transport. It's important for a lot of people. This photograph was taken in Dundee. That range is not weather dependent as it can be for some battery systems. So, you know, that is an example of the customer package, the way that we try to take the advantages of the technologies and package it into something that can be adopted by companies running commercial operations now. Here, I'll explain this slide, but there are two quite different approaches to rollout. On the left is the national top-down approach, led by fuel. This is a map from the first phase of the H2 mobility program in the country, something I was involved in, which was looking at what do you need to create to enable a mass market for fuel cell vehicles. The approach we take is not this approach. The one on the right, that's the Metro Mayor of Liverpool, you may recognize him, with one of our buses. In a bus deployment, you're not looking at a total network, you're looking at one filling station, and one filling station that you can load heavily so that the unit costs are as low as they can be. So what we do is very much, it's bottom up, it's vehicle led, it's fleet led, and that then will form the basis eventually of a national infrastructure, we hope. You have to start, the vehicles can be moved around, the fuel tends to be much more, the economics of the fuel, particularly in the availability, are much more variable, depending on where the energy comes from and the local circumstances. So we look at fuel, we look at people who are motivated to operate zero emission vehicles and have the need for the performance of fuel cells. We look at what support is available to defray capital costs on early units. We then do the full use case analysis to demonstrate the benefits and the costs of switching to hydrogen technology and use that to develop the business case. Then it's about deployment. And as I said before, it follows up with very close technical support and then data collection and demonstration for validation and further improvement. This is the way we see the heavy duty market going. Buses, reliable, sort of regular urban start-stop uses based on depots. That's a place to start. They're very highly visible. The air quality benefits are valuable. That's where we've started. Municipal vehicles, we're doing bin lorries now. These are also urban start-stop vehicles with some of the same benefits, but they're heavier and they use more energy. So it develops the economics in a way are better, and it also develops the market faster. The next stage then we think will be urban distribution. And then finally, we will see motorway uses, long-haul trucks. So that's the last bit there, the long-haul trucks using public refueling networks. That's where the real big win is. But in terms of what we can practically deliver now and what customers will pay for, we're starting on the left-hand side. So thank you very much for your attention. I apologize for the problems with the sound. I hope you've managed to follow it. And I look forward to answering any questions and a conversation after the next presentation.